All right. Well, no pressure, no pressure. Off the lights. Hello, everyone. So today I want to be speaking about a subject I really, really love. And that's the whole world of cryptocurrencies, blockchain, the algorithms there, and another part, which is the world of frontend, and connecting these two things together, which I think now are probably the biggest problem in the blockchain world, making stuff accessible. So in this talk, I hope we're going to build an application together from the start until the end, with a real contract, deploy it, and access it from a React application. My name is Boris. I've been developing for quite a while now. Started managing exchange servers a long time ago, building USB stacks for embedded devices, Ruby on Rails, and the past few years, front-end development with Angular, React, and Redux. I got into blockchain somewhere in 2013. Back before Ethereum existed, doing real Bitcoin stuff, and I never lost a passion for it, and always enjoyed looking this field grow and become what it is today. A little shameless plug, our section edition of Redux book is out. It's completely free, so if you're doing Redux and want to get some new ideas, you go and download the book. All right, and I like cats, which you might have noticed, and you see again. So I wanted to speak about a real application, domain names. Let's say tomorrow you want to register a domain of your own, boris.com. You probably will go to something like a private company to do that. Most TLDs are private companies in a way. So that means while I own the domain, in reality, it's not really mine. Someone can take it from me, maybe legal action or something else. But the world of blockchain offers something really new. I can register my domain on the blockchain. It's completely decentralized. There is no central party that can govern it, hopefully. That means I really own that asset. I can, of course, sell it to someone, pass it to someone, but I own it fully and totally. So I thought that might be a great idea for this talk, to build a simple domain service that can resolve strings, domains, to IP addresses. I even went ahead and created a simple React-based application that can resolve domains and register them. Now, you might notice the spinner here, and that's because nothing is really working. I don't have any backend. I don't connect a real domain service. Actually, I have it all stubbed here in my database file. Two functions. One that gets a domain and should return an IP, and a second function that should get a domain and IP and register it somewhere. And we'll try to tackle these two things and connect them to a real blockchain. So my talk is not about Bitcoin, it's about Ethereum. And the reason behind it is that Ethereum is really suited to applications like the domain service. Because Ethereum in its base is kind of like a database. So it's not a tabular database or a document-based store. It's kind of like a database where you can just throw data in. And when I say data, it can be anything, strings, numbers, and even things like mappings, something that maps from a string to a number. Another important thing that we'll talk about a bit later is I can also store code inside the database. So first of all, what's blockchain to those that are not really familiar with it? I said it's a database, so why do we have blocks? You can kind of think about it as a Git repository with one branch. We started our really big commit, and slowly we add more and more patches on top of it. So if you want to know the current state of a system, I just look at the top of the branch with all the patches going down. And that's pretty much the blocks. So let's think about a new example. Actually, it's the first time I'm speaking about it. I'm going to be launching a Boris coin today. And for pre-launch, I decided to distribute some coins around. So I have 10 coins on my account, and I have 20 coins with Adam, my friend. And this morning, he was really nice, and he loaned me in euro so I can buy coffee. And instead of giving him a euro, because it's just currency, you know, I want to give him a Boris coin back. So I plan to log in into my application and change the balances so they reflect the change of amounts. Now, if it was a real database, what I would probably do is just do 2 transactions, right? To change my balance to 9 and increase his balance to 21. But since all the code is running on my laptop, I can probably just open the JavaScript code and change it a little bit. So I'd never deduct from myself, but just give Adam the money he's owned. But I know that Adam is sitting somewhere in the audience here, so you might be sitting there and thinking, like, wait, it's JavaScript. So you can go on his computer and change the code to be something like this and become instantly rich. So we kind of have a big problem here. If everyone can change the code, we don't really have any meaningful data sitting in the database. We want everyone to be running exactly the same code that does a lot of different checks and verifications. And since I'm not going to be using any server at all, and I want to be using my JavaScript application to speak directly to the server, to the blockchain, there's only one place I can put my code in, right? And that's on the blockchain. So I'm going to move only leave front-end code on the laptop and put my code on the Ethereum blockchain. This means that if I want to change balances, I no longer just change values. I have to call a function, for instance, transfer. And the function, of course, will validate that I'm allowed to transfer money. It will check that I actually have enough money to send, and maybe even verify that Adam has an active account on the system. Right? So this makes a lot more sense from security perspective. So I'm going to jump back again to real parts of Ethereum. In the world of Ethereum, we have two types of accounts. The accounts that hold Ethereum coins, that I'll mention in a few minutes, and accounts that hold contract code, which is code and data. Every account has a unique global identifier. So I can have multiple personal accounts with money in them, and I can have multiple contracts, like any one of you. In each of those contracts is also built of two parts: the code itself and the data. For instance, the balances or the registered domain names. Now, you probably can't see it because it's really tiny intentionally, but that's not really code. That's a sort of bytecode. Each node in the Ethereum network has something called EVM, an Ethereum virtual machine. So they can execute a special bytecode. Now, probably none of you want to be developing in bytecode. Maybe some masochists, but it's really hard. So the open source community created some higher order languages. The most common one being Solidity. Now, the reason it's really common is because it's very, very similar to JavaScript. I'm going to be showing you a contract in a few minutes, and probably all the JavaScript developers here will find it really easy to understand. Now, it's not really pure JavaScript, because the Solidity language have a lot of constructs and changes, so you can build more secure contracts. But the base is very similar. So let's see how we turn this bytecode into a nice, readable Solidity code. So first I'll define my contract. We'll call it domains. And then I'll define all the data I want to store inside of it. So in our case, I will insert a mapping that takes a string, a domain, and gives us back an IP. And here I'm going to be using an unsigned integer, which has 4 bytes inside, which is exactly what we need for an IP address. That's the most smallest and concise way. And now we need to define at least one function, right? We want something like resolve. I'll give it an IP address. It will look in the mapping and give us back, I'll give it a domain, look in the mapping, give us back an IP, and another function for registration. A domain name, an IP, and it will just add them to the mapping. This code should be really easily readable to everyone. Small warning, don't just go ahead and start writing Ethereum contracts. A lot of money has been lost because people just started doing that. You should really study the language and the side problems that can happen there. All right. So that was like a very general overview. We covered only a very small part of the Ethereum network. If you want to get more into this development, you should really understand how the consensus protocols work, what is proof of work, and how the database synchronizes with other nodes in the server, in the network. Right? We don't have just one server here. Before I jump to live coding, though, a small thing we need to think about is the reads and writes. So let's look at our contract at the 2 main lines here. So when I try to resolve something, and I'm speaking as a node now, I'll just look at my database, I map between a string and a number and give it back to you as a client. Really simple and easy. But if you want to register a new IP, things become a lot more complicated. Think about someone trying to spam my network and register, I don't know, 1,000 IPs or 1 billion IPs. And since the same database is going to be replicated for the whole Ethereum framework, they can make it really, really huge. So we want to limit people so they can't just fill the database with crap. Another problem is, once as a node I updated my local database, I have to update all the other nodes in the network, which is going to be quite a bit of work, especially since we're using proof of work now. That means as a server, I need to find a way to limit you guys from doing bad stuff. And for that, we actually use the Ethereum currency. Its original intention was to pay nodes and miners for adding stuff to the database. The more data you want to add, the more you will pay. The more instructions you want to run, the more you will pay. And of course, every block that is created is also being, the miner gets a bit of money from that. So that means reading from the Ethereum network is usually completely free. Writing to the Ethereum network costs real money if you're working on the main network. Cool. So let's try and get all this to work in reality. And we're going to jump to the more exciting parts, live coding. So I'm not going to be using the real Ethereum network because it takes quite a while for new blocks to be formed. I think it's about 27 seconds now. And it's going to cost me money, which I don't want to spend. What I don't want to do is run a local server. So there's a nice tool, Ganache, that creates a local private node just for me. It gives me a bit of Ethereum. There's quite a few accounts here that have 100 Ethereum. Unfortunately, that's not real money, because otherwise that would be like $20,000 now in each one. But it gives me a really nice way to test stuff locally without any installations. Another tool I'm going to use is the Remix ID. It's a web-based ID that's really nice to play around with contracts, deploy them, and afterwards see what's happening inside of them. So we got our contract already here. There are a few keywords that I didn't have in the presentation that are needed now to make the contract more concise. And what I want to do is really try to compile it. So we hit the compile button here. Well, you don't see it, but actually something happened and the compilation occurred. And we can look at the details, and here we'll see the bytecode generated and quite a few other things that the compiler have done. So happily, my contract is compiling correctly, which is already a great thing. And now I want to run it. So in my case, I have a local network. So I'm going to connect to it. We're going to the web provider and connect to localhost. And let's see what happens. If you watch the right side of the screen, I'm trying to zoom in unsuccessfully, unfortunately, you will see we have a list of accounts with 100 Ether inside, which are exactly the accounts we had in my Ganache. So I'm connected to my local node. And now, let's try to deploy my contract. So I only have one contract compiled. I'll click the deploy button and hope for the best. Well, according to the ID, the contract was deployed. I can take a quick look inside my Ganache server and see that really a transaction happened. Another interesting thing is I can see my amounts of Ether went down from 100 to 99.9999. That means I actually paid the local server to create a new contract. So the payment is really happening. I can actually deploy it a few times. So I have now 3 deployments, but each one is sitting on a different address. Each one is completely unique. Let's play around a little bit with the first one. I hope you can see it. It's a bit low here on the screen. Let's try running the register function. I'm going to register google.com, and here the IP is an unsigned integer. So since I can't really convert it mentally, I'll do something like 20. That means the IP will be 00020. Let's hit the register button. Again, the Ethereum balance went down a little bit. And let's register facebook.com as well. And I'm going to give it an IP of 00060. Another peek inside Ganache, and we can see that I have 2 contract calls, one to create the Google mapping and the second to create the Facebook mapping. So things are really happening on the local server. So let's try to look up stuff. Let's try to resolve facebook.com. And 60, perfect. So we have a contract, it's deployed on the server, we register 2 domains, and we can actually read back the values. But that's all happening inside this nice ID, and obviously we don't really want our users playing with IDs. We want to give them a nice, beautiful interface, which is something most Ethereum developers don't really do. So let's try to make this app work with a local node. Now, the best way to communicate from JavaScript with Ethereum is to use an existing package. It's already in NPM. The Web3 NPM package gives us a very nice and robust interface to do lots of stuff with Ethereum nodes. Since I already have it installed, I'll just try to use it with you together. So let's go to our index file and just start from scratch. I'm going to import Web3 from the Web3 package, and I'm going to create a new instance of a Web3 connection. New Web3. Now, since I want to connect to a specific node, right, I might have a test network, a production network, and a local network, we actually have to create some kind of connector for Web3. In my case, it's a local node, so we'll create a Web3 provider and use the HTTP provider for that. Just a regular HTTP connection, HTTP localhost on port 8545. I'm going to add a debugger here so we can try to see if things are actually working for me. OK, no errors. It's already good. Web3. Let's hit it, and looks like it's working. I'm not sure yet, but something is looking much nicer now. So now I have a connection to my node. But what I really want to do is speak with the contract, right? I want to ask the contract to resolve domains, and I want to ask the contract to register domains. That means we need an instance of the contract itself, or a connection to the contract. So let's create that as well. Const contract, a new Web3, Ethereum contract. Now, running this won't really work, because there are a few things missing. As you've seen before, I deployed 3 different contracts. So we have to tell which contract we want to speak with. So I'm going to copy the address of the first one. That's where we put all our mappings so far. And even now, we're not really done. Because if you think about it, from my perspective now, what we have saved in the contract is just a bunch of bytecode. How do I know what kind of interface it gives us out, right? I can try parsing the code and understanding what functions exist inside, but that's going to be really complicated and weird. What we need is some kind of header file that tells us what functions are exported by the contract and what parameters the functions expect. So in the world of Ethereum, that actually exists already, and it's called an ABI. Once we compiled our contract, we got both a bytecode and something called an ABI. I'm going to copy it now so we can take a closer look at it. And copy it inside my project, a new file, contract, JSON. Oh, it already exists, perfect. I'm going to overwrite it with a new contract. And as you can see, the ABI is just a basic JSON file. Currently, it has 2 objects inside an array. The first object describes the function whose name is register, and it gets 2 parameters, a domain and IP. And the second object, again, a function that's called resolve that gets only 1 domain. So that's our header file for the contract. And we'll have to use it to be able to communicate with the contract. So I'm going to import it as well. Import ABI from contract. All right, that's actually the first parameter to the contract creation. And let's run the code and see what happens. OK, no errors so far. Let's take a look inside the contract we created. And we can see here in the methods, we actually see the register and the resolve functions. So maybe we'll just try using them already. Contract, methods, resolve, give it, let's say, google.com, and see what happens. So we don't really get a value bet, right? We got some kind of weird structure. And that is because if you want to call a function in a contract, we have to decide how we're going to call it. In my case, I just want to ask the server to do it for me. I don't want to pay anything because I'm doing a read request. So I'm going to use the call function. Now this looks much better. I get back a promise. And let's see what this promise resolves to. Let's just print out whatever the promise returns. So I'm going to let the things run, and we got 20, which is exactly the number we registered for Google. Let's try this again. This time I'm going to give it, instead of Google, I'm going to try it Facebook. And hopefully we'll get 60 back. Cool. So we're using Web3 to connect to the node, to our local node, and getting a value back. I'm going to take this nice code and use it inside our real React application. So remove the debugger, of course. No need for that anymore. Remove the fake resolve. And replace resolve with contract, methods, resolve, domain, and do a call. OK, let's see if it works. Perfect. 0020, 0060. And now let's try to make this one work as well. So we can register a domain. Now, if I click it now, nothing really happens, right? Because we didn't connect it at all. Well, let's try to create the code directly here without the console anymore. So we go to the contract, methods, register, give it a domain, give it the IP. But now we cannot do the call method anymore. The reason being, the server will expect payment for the change. Right? It's not going to do it for us for free. So what we'll have to do is call the send method and tell it which account is going to pay for it, because this is not free for us anymore. Sorry, from. And let's take one of the accounts we got in Ganache and steal some money from it. And let's give us application a way to try. I hit register, but nothing is happening. Let me try refresh. Wait. So the data actually got saved in the server, but the UI didn't get updated. And the reason behind it is because we didn't really listen to changes, right? I just write stuff to the blockchain. The correct way to do it would have been to add events to my contract. So every time someone registers a domain, transfers a domain, or does any changes in the database, I would like it to send an event out. And that way, inside of my frontend, I would be able to actually listen to events. I would say the contract at a specific address, listen to all events of a type register or update, and update my UI. So we can really work with blockchain without any server in the middle. Everything can get done directly from the browser to my local node. All right. Let me jump back to the presentation for a second. So I want to do a quick recap of what we've done. So we wrote a contract of our own. We had our local node running. We deployed the contract, right? And we connected it successfully with JavaScript to a React application. And while it all worked, in reality, you probably won't be doing things exactly like that. Because there are a few things we have to consider. So first of all is the whole idea of a node. Now I just went ahead and connected to a node like locally. But in a real production environment, I will have to set up a server, do a lot of DevOps, security, updates, a whole of a mess. So if you want to really start running with Ethereum, you can use a startup like Infura that already hosts a number of Ethereum nodes, and they're doing it completely for free. CryptoKitties, for those familiar with it, we're using Infura as the servers to connect to Ethereum, not running their own servers. In the Ethereum network, there's also a number of different networks. We have, of course, the live network, where all the real money is being changed and real assets are moving around. There are a number of different test networks, each one with slightly different implementations and ideas that the Ethereum developers want to put out in the world. That should definitely be your next step before you go to real production. And of course, a number of private networks, both running locally in your machine and in your organization, if you're doing more tests. But perhaps the biggest thing is what I've done with Remix ID. I wrote down a contract, I deployed it manually, and you can probably imagine how dangerous that is if you give developers a simple tool to deploy stuff to production. Versioning can change, tests need to be run. So the Remix ID, while it's really nice for playing, it's not really meant for production. I would strongly suggest that you use something like Truffle. It's a library that manages the whole life cycle of a Ethereum contract. different versioning, testing, deployments to test environments and production environments, everything in one place, it's sitting inside Git, and very well documented and working. Also here, I've been using Web3, which is basically a really low-level interface to an Ethereum node. There are a number of different libraries that try to make it more user-friendly for developers. One of them is Drizzle, which creates something very similar to Redux Store, but that's connected to an Ethereum node. So from React developers' perspective, it will feel probably almost like at home, with things just magically working. And then another really suggested tool is Ganache. Before Ganache, if you wanted to run a local network, you would have to download stuff, compile stuff, run a long list of command line commands to generate your first database and sync. With Ganache, you just download the app, double click, and you have a network, and you can start playing around with it. So this was like a really, really, really fast recap of Ethereum. My main goal here was to show you how easy it is to do it. And hopefully, you will take some time, maybe over a weekend, a few hours. Setting everything up on a Mac takes, I think, like 20 minutes, no more. And then if you spend a few hours on it, you'll be able to take this sample example, add ownership, add maybe transfers, see how you can pay for domains, and really get a feeling for the whole tool, how you use React and the blockchain. No one really knows where the blockchain is going, but I think it's really important for us to understand at least how it works and how to work with it. Because hopefully, when it blows up again, in a good way, you'll have a chance to work on it, and it's really fun. All right, thank you very much. I hope you enjoyed the talk. Thank you. We have time for questions? Perfect.
Perfect timing. Thank you, Boris.
Thank you.
We also have some questions for you.
All right,
Ready to answer?
I hope they're really easy.
How do you fix bugs in a deployed smart contract? It's not possible, right? Or
it's
is
not.
it?
Well, it's kind of not possible. There are a number of approaches to it. First, you can call up every Ethereum developer you know in the world and beg them to create a special fork, which probably won't happen. But there is a different approach. Some people create contracts that are actually upgradable. So the contract itself just points to the production contract. And if the code in your production contract is not good, you go to the original contract and just change the pointer to another address. So theoretically, it's possible, but then you kind of break the whole idea of Ethereum, because the contract you put online is changeable. So then people can't really trust your contract. So just don't write bugs in your code. I don't know, what's the problem? Sounds, I don't know, easy.
What about removing an existing contract once it's verified? If not, how is Ethereum in compliance with relevant EU laws on removal?
Whoa, who upvoted that? If you're the owner, you can delete a contract. Again, if you took care, if you made sure you actually can do it, but you can delete contracts. If you think about it, the same way I deploy a contract, I create an account with code and data, I can delete that same code and data and free everything up and remove it from blockchain. The only problem is I cannot delete history. So you won't see it looking at the current state, but looking back at the blocks that were created before, it will be there forever. So you really can't delete history, much like the real world. So not sure about the compliance. That's not a question I really know how to answer.
I think it's fine. Can a contract call another contract?
Hmm?
That's the next question. Can a contract call another contract?
Yeah, of course. So actually, it's a really good question. You can create multiple contracts. There's a lot of libraries been created that you can use from inside the contract itself. The example I gave in the beginning, I can create a very simple contract, but every call to that contract gets proxied to another contract. So if that second contract have a problem, I can just fix it, deploy a new contract, and make my proxy go to the new one. So you can definitely use multiple contracts, communicate between them, but there's only one caveat here. Most of the bigger bugs we've seen in contracts on the Ethereum network were from contracts calling other contracts. So it's really, you should be super careful doing that. But it's definitely doable.
Sounds good. Thank you.
Thank you very much.